Hi guys, so for this video, I've created an A-star level exam question pretty much booklet that combines a bit of conservation of energy, there's a bit of conservation of momentum, there's a bit of Suvat equations, and there's a bit of definitions as well. So yeah, let's get started. It says explain what's meant by gravitational potential energy without using an equation. Now in A-level physics, a lot of the time you can't just use an equation to define whatever it wants you to define. But without using an equation, I'm going to cheat a little bit here because we know that the equation is mgh. We know that it's dependent on mass. G is always constant, but it's dependent on height. If we have two objects that are the same mass, the one that's higher is going to have more gravitational potential energy. So that's what you want to mention in your answer, something relating to height. So the position of an object or the energy of an object due to its position above the ground or due to its height above the ground. That would definitely secure you the mark for that question. Moving on to this next part of the question, it tells you that it initially is thrown vertically downwards, so we're going to assume that it accelerates due to gravity. It hasn't told us that there's any resistive forces, so we can assume that this is the only form of acceleration. It starts off with a speed of 15 meters per second and it travels 2.8 meters before it hits the ground. After hitting the ground, it rebounds with a speed of 12 and yeah, just like here, it says air resistance is negligible. It then asks you to calculate the speed of the ball just before it hits the ground. Now, what that means is if you form a Suvat equation looking at the whole direction vertically, the acceleration, like I mentioned, is in the direction of gravity, meaning it will be a positive 9.81. Now, in maths is where you use 9.8, but A-level physics tries to use 9.81 for the acceleration. If instead the acceleration was vertically upwards, then it would have been against gravity and we take it as minus 9.81. The height that it falls is the displacement that we're taking for this question, so that's 2.8 meters. A bit of a side note, but you always want to have 3 known variables and 1 unknown variable. That then allows you to pick out one of the Suvat equations depending on the question. We know that its initial velocity that it's being dropped from is 15 meters per second, and we want to find the velocity just before it hits the ground. That's like the final velocity in this part of the motion that we're considering. Now the equation linking S, U, V and A is V squared equals U squared plus 2AS. So let's substitute into that equation. So V squared, that's what we need to sort of calculate, is equal to U squared, which is 15 squared, plus 2AS, which is 2 times 9.81 times 2.8 for this question. Now, V would just be the square root of all of that. I'm going to cheat a little bit and just write square root there. And that will give you 16.7. I'm not some kind of math genius. I just did this beforehand. That's why I know. Great, let's now move on to part 2. So just to clarify, that means that it starts off with a speed of 15 meters per second, and after accelerating due to gravity, just before it hits the ground, it has a speed of 16.7 meters per second. We then know that it rebounds off the ground with a speed of 12. It's asked you to find the energy transferred during the impact with the ground. What form of energy relates to speed? Well, it's kinetic energy. We know kinetic energy is a half mv squared. Now, one thing that you may have noticed is that the speed decreases suddenly after the impact. If the speed decreases after the impact, that means that the kinetic energy decreases after the impact. But what we know about the conservation of energy is that it has to go somewhere. It doesn't just disappear. So what we can say is that the kinetic energy before it hits the ground, it goes into kinetic energy after it hits the ground. But then where does that difference in energy go? That difference in energy is what's transferred to the ground. And that's what we want to calculate. I think these are the most difficult types of questions to spot in A-level physics because they come up pretty randomly, just like they did here. Okay, I'm going to change the thickness of the pen and yeah, we can make this even simpler. To find the energy transfer to the ground, we can take away the kinetic energy after from both sides. We can say kinetic energy before, take away kinetic energy after, equals energy transfer to the ground. Kinetic energy before is a half times the mass, which is, well, the mass of the ball is 0.2 kg, multiplied by the velocity squared, which is, okay, so another mistake students make is they take 15 as a velocity squared, but because we're specifically focusing on the impact time, we take the velocity just before impact. So that's 16.7 all squared. And you take away from that the value that you get when you do a half times mass times the speed after squared, whole squared. Now you might be thinking, the velocity, would it be 12 and 16.7? Because what do we know about velocity? It's dependent on direction, meaning that if the velocity is positive in one direction, it has to be negative in the opposite direction. So let's take into account of that. If this was plus 12 and minus 16.7, it actually wouldn't matter in this case because we're squaring the values, if that makes sense. So it's going to end up as being positive. Now, when you subtract these, you get 13.5 joules. That's the energy that's transferred to the ground. Let's now move on to this last part of the question, which, well, let's have a little think about what to use. It's asked you to find the magnitude of the average force exerted during the impact. Again, we're focusing on the impact. And it's also giving you time. Now, with A-level physics, it won't give you a variable for no reason. There has to be some use of time. So how does force relate to time? Well, something might come to mind, impulse, right? So we know impulse is equal to force multiplied by time. What else is impulse equal to? It's equal to the change in momentum. Breaking that down, momentum we know is mass times velocity. Well, the mass of an object, it doesn't change during this whole motion. So if there is a change in momentum, it's caused by a change in velocity. We can say that force times time is equal to mass times change in velocity, divide both sides by time, and we get that the force is a change in momentum over time. Or you can say the rate of change of momentum, because the rate of change of anything is how it varies with time. Let's look at change in velocity a little bit. A very common mistake that students make is they just look at the change between 12 and 16.7. But like we mentioned, velocity is dependent on direction. If you take it as positive in one direction, it has to be negative in the opposite direction. It doesn't matter which one you take as positive as long as the opposite one is negative. So this one could have been positive and this one would then have to be negative. It won't make a difference. Actually, the answer asks for the magnitude. So whether you get a positive or negative answer, you're just taking the size. So let's input into that equation now. We have the mass, which is 0.2 multiplied by the change in velocity. Now, you can think about this quite logically. What's the change between 16.7 and minus 12? Well, it's 16.7 plus 12. That's 28.7. And you divide all of that by the time, which is already in seconds, 0.065. And that'll get you a value of 88 newtons. That's the answer to this question and the answer to the whole question. I'll just zoom out so you can see all of it. But yeah, if you have any questions about it, just let me know in the comments. Otherwise, yeah, be sure to like the video and subscribe. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.